Good morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. In this video class, I am going to teach you stack storage allocation. Stack storage allocation. Okay, so last video class I taught you storage organization. This is also continuity of that storage organization. How the storage is organized, that's what I told you in the last video class. Code section or code space, static data space and heap data space and free space, then stack data space. Okay, so continue. If they ask explain storage organization, you have to continue this also, including that storage organization. Okay, the top heading is stack storage allocation. So there is a two ways of allocation I told you, heap storage and stack storage. So this is one of the program that was taken, skeletal program taken from quicksort algorithm. This is not the full program, you have to understand. For this stack storage example, we have taken a small skeleton of that program. Okay, based on this, there is in stack storage allocation, there is activation tree, and activation record Okay, these two you have to explain in this stack storage allocation. So this is the skeletal program that was taken from the quicksort algorithm. See, int a of 11 void. Why this is taken is this says mainly this quicksort algorithm has three, that is read, partition and ender, main and quicksort. Okay, there is a four main parts in this quicksort: main function, quicksort, partition and read array. Okay, read, partition, quicksort and main. Okay, so how the control is traveling from one to another procedure, that's what they are going to explain in this skeletal quicksort program, using this skeletal quicksort program. So first, this program is converted into activation tree. This is activation tree, and before that activation procedure, this is also activation tree. How this program is executed. See, first it entering into main function. Normally we know the C++ program, it checks the main function main, and second the control goes to read array and then quicksort and then partition and then leave partition and then ender quicksort and etc. and leave quicksort and next ender quicksort, leave main. Okay, so this is the way the control is processing. Clear? This is not an accurate program, quicksort program. This is one of the skeleton taken from the quicksort and it is converted into tree. See, main function, first it enter into main and read quicksort, read program, enter into read and enter into quicksort. Okay, so value is taken from this program, and then quicksort enter into partition and enter into quicksort, enter into quicksort. Okay, and then leave partition, that is control is not or stack is not pushed and popped. If it is enter, it is pushed. If it is leave, it is pop. So first push into read array is pushed into stack, and quicksort also pushed into stack, partition also pushed into stack, that is value 1,9. Then pop from the stack, partition is popped from the stack, again quicksort 1,3 is entering into the stack, that is pushed into the stack. Like this it executed. Okay, so activation trees comes like this. Clear? So this is the way of allocating memory in a storage, right? So next very important topic is activation record. So stack organization I told you, push, pop, read array, enter into read array, enter into partition, enter into main, etc. Leave main, leave partition, leave quicksort, etc. That's what we studied in the previous section, right? So now it is a activation tree, that is activation tree. Now it is activation record. So what is activation record is, activation record consists of 7 fields. Activation record consists of 7 fields. A very important question. Activation record consists of 7 fields. First one is temporaries, second one is local data, and saved memory status, and optional access link, and optional control link, return value, and actual parameter. 1, 2, 3, 4, 5, 6, 7. 7 fields. Activation record consists of 7 fields. So last session I taught enter quicksort, enter read array, enter read array, enter main, leave main, leave quicksort, leave read array. These are the functions that studied in the last session. So when suppose this may be one procedure, this may be another one procedure. Okay, so what is the use of this activation record is, maybe this is P1, maybe this is P2, some other P3, etc. There is a different procedure or modules. Okay, whenever the procedure is called, procedure P1 is called, this activation record is also created. Okay, that is whenever this procedure 1 is entered into stack, this activation record is created. So when this what is the lifetime of this activation record? Whenever this procedure is popped from the stack, this activation record is deallocated or it died. Clear? So if the second procedure is entered into stack, the activation record for corresponding procedure will be created. Okay, if the second record is exit from the stack, the activation record is also deleted or exited. Okay, this is the activation record. So what is activation record? They have 7 fields. So this procedure's temporary values are saved in this field. Okay, also this procedure's local data are saved in this field. This procedure's memory status, that is next execution address, is saved in this field. And access link is saved in this field, control links is saved in this field, return value is saved in this field, and the parameter, actual parameter is saved in this field. So the 7 fields for the procedure 1 is saved in this activation record. What is the use of this activation record? See, I told you, whenever procedure 1 is entered into stack, corresponding activation record is created. So whenever this procedure 1 needed some temporary values, some local data values, memory status, parameter, controlling, access controlling means where it want to go, optional controlling, access controlling, these information will be placed in activation record, and this procedure taken from this activation record. Clear? So if this procedure exit from the stack, this corresponding activation record is deleted, and whenever procedure 2 is entered into the stack, second activation record for this procedure is created. Okay, so easy access, for procedures easily access, we need activation record. Okay, so this is the main use of activation record. Lifetime of activation record is whenever procedure call, activation record is created. Whenever procedure exit, activation record is deleted. Okay, you know calling sequence and call sequence. Calling sequence means, if the procedure need information from P2, this is call sequence and this is calling sequence. Okay, and it gives the information to this. If it is want to need information from P1, this is call sequence, this is calling sequence. Okay, and you should know, you just refer our notes, you should clearly understand what is calling sequence, call sequence, and variable length, parameter, etc. Okay, so this session I taught you what is activation tree and what is activation record, how it is saved in a stack using a memory allocation. Okay, thank you.